All right. So for part two of our intro to databases lecture, now that we've encountered some of the challenges of data validation and keeping data integrity, especially if we're just working with our data in files and working with Python, we're going to look at a database engine, Postgres. Um, as mentioned, there's a couple different relational databases out there. Postgres is extremely popular. It's open source. It's used by a lot of big companies. The important thing to know, though, is that all these relational databases, they all use this language that we'll learn a little about today, called SQL, or structured query language. And once you learn it for one, you really learn it for everything. There we go. And they call it a domain-specific language, which is like a mini programming language to solve a really specific problem. So SQL is created specifically for working with data in these relational databases. And it's kind of a deep well if you go down it, but we're not going to go too deep down it. It was created in the 70s. It's been around a long time. I kind of think of it like a shark or an alligator. Like nature kind of perfected the evolution of the shark like millions of years ago, and it hasn't really changed. And that's not really true with SQL, but it sort of is, and it's stuck around for a reason. So Postgres, the database engine, also has a lot of pretty advanced features that we'll eventually scratch the surface on. As you all get into it, it actually has pretty incredible documentation. And if you want to go deeper, its getting started tutorial will actually take you pretty far. And it has some of the best documentation around. And I would say it's more readable than other documentation, though it is pretty dense. But pretty much any question you have, you can find answered in the Postgres docs. So when working with relational databases, a lot of the times we want to use a visualization tool. And Draw SQL is one of the more popular ones. You don't have to create an account, but it can make life a bit easier. And by the way, our plan is we're going to visualize stuff a bit. We're going to see how to use Postgres from the command line with this program called psql and where Postgres lives. We're going to cover key commands. We're going to cover creating a database and a table. We're going to cover how to write SQL files in VS Code. So we have all the nice features of our VS Code editor, but how we can then run it using psql against our database, and how to import CSV data and query data. So this team is from several platoons ago, but we're just going to make a new diagram. We'll call it Buffalo Hello. It can be private or public. It doesn't matter. Tools like Draw SQL, there's a couple of them out there. They will get a little more specific in terms of some of the details around like a data schema. So we might as well choose Postgres, the kind of database that we're going to build. And we're going to hit create diagram. And so now, and I do want to hop back here for a moment because I want to pull up our Python code for the student class. So once we learned object-oriented programming, we kind of learned, like, if I want to create something to model my universe, I'm probably creating a class, right? And in this case, we're making a student class. In a relational database, we make a table. And a table, again, your mental model should be very similar to an Excel spreadsheet in that we have columns that have names. And then once we define the table and we define the different column names and type of data in each column, we're able to enter rows of data, right? And so what we're doing now is we're defining our column names, and we'll see we get to do, in fact, a bit more. So we're going to make a table named student, and we'll put it over here. And now I can make different They're called columns, or you'll just hear them called fields. And we can have an ID, and I can choose the type. And there's a lot of different data types in Postgres. There are, if I may emphasize, a lot of different data types in Postgres. We're not going to really dig into them too much today, but there's a whole bunch of different number types. There's a type for money, for binary data, for date times, for just times, for time zones, for intervals of time, for Booleans, what's called enumerated types. If you're dealing with like geographic data, or you need to, for some reason, deal with geometric stuff, you've got geometry types. You have types for network addresses, for text, for JSON data, which is really powerful. You can even have array types, though we kind of try to avoid these, especially starting out. But already, I think you all can see where this starts to offer some advantages over using just Python, because the Postgres database engine will enforce rules around each of these different types. But the type that we're going to care about now is our ID, which is definitely going to be an integer, which is a really good practice. And we're also going to make it what's called a primary key. And this does two things for us. Postgres will make sure that it's always unique. It will take care of incrementing it to create the next value. And when we create table relationships, which we won't get into today, this is how we connect the dots, right? So over here with our student table, this is our primary key ID. And then for lockers, and we see it over here. And in fact, I'll just make this red to help kind of make all the colors the same. And then for lockers over here, this is the primary key for lockers, right? So a primary key is a unique identifier for a row of data in a table. And we can add more columns of data, like a first name. And I can make this, it's called varchar, which basically means text. And I can even say how many letters it should be, how many characters. And let's say the first name can't be more than 20 characters. And let's add a last name. And let's also say that it can't be more than 20 characters. And this is a visualization tool. And let me actually make the font size a bit bigger. And hopefully that's a bit more readable for everyone. We're actually going to write out SQL code to do this same thing later. But right now, this will help us kind of visualize our table before we dive too far in. And as I'm creating these columns, I can indicate if it can be null or not, if an empty value is allowed, and these should not have empty values allowed. And now we've got age, and age should not be a big int. In fact, it should just be an integer. It should probably even be a small int, because in computing terms, a small int is probably, I don't know, like a couple thousand or something like that. And then we have, in fact, their grade. And this is a varchar. It's a letter, but it's A, B, C, or D. So we're going to say it can only be one character. There are ways to get more complex with our data validation, but just to get started, this is pretty good. And hopefully we can already start to see sort of like the power of this approach. So this is just sort of like a visualization. And to use the locker example, because this is, I think, a really nice, simple example. If we had a locker table, our locker would have an ID that's a primary key, and we'd add a column, and this would be the locker number. And this would also probably be a small integer. And it's not null. And we're going to say that it has to be unique. And then I can kind of, let's say, in fact, that over here, we keep track of what student the locker is for. And so what I would do as I'm kind of drawing this out is I would connect these two. And as we'll get into relationships later, we're not really going to explore them today. But again, I just want to build out a visual example for us to start to get a sense of when we're talking about a relational database, what we mean is that we have these relationships between tables of data. Alex, yes, sir.
So is what makes using SQL powerful is that the way you're um declaring that ID should be a big int and that grade should be varchar1. Is that basically like getters and setters?
It's it's different from getters and setters.
Okay.
It will accomplish a similar goal, but it's different from getters and setters. Um, and the goal is validating data, right? And I think that's what you're getting at. That if I make a getter and a setter, I can use the setter to protect the first name to make sure that it's only like alphanumeric, right? Like we do right here. So they're doing the same job, but they work in totally different ways. And this is just baked in to SQL and relational databases. Like I can't create a column without giving it a type. And then there's a lot more validation that I can add. So I think the way to think about it is a setter is one way to validate data for like for a Python object or a class. And in SQL, the validation is just built in when we create columns. Yeah, great question. And in fact, let's create the student table now. I don't want to get too far into this because there's a little bit of sort of like system command line stuff we have to look at to make sure we have a good understanding of where Postgres lives on our computer and how to interact with it on the command line. But let's just write some SQL so that we can see along with this visual aid some tables. And we'll worry later about how to run this SQL in Postgres. And in fact, I probably should have named these plural, which is generally considered a good practice, I think. The important thing is just to be consistent. And so as I'm creating a student table, I can use a special keyword called serial that basically tells Postgres it's called auto incrementing, increasing this for me. And I'm telling Postgres this is the unique identifier. When I want to find John, we're going to use ID to find John. And let's be generous. Let's let the first name and the last name have up to 50 characters. And age will be an integer. And grade will be a character of only one. And let me hop back to my diagram. And so here's the SQL we would write to create this table when we're working with Postgres. Tom, yes, sir.
So you said SQL takes care of the ID for us, but if we're like reading this data in from a CSV, for example, like we are here, the ID numbers provided for us. So will that cause an issue with, putting the data into the database since it's already trying to serialize the ID for us?
That's a really good point. Yes, it can. That can get a little trickier, and we'll see how to handle that later. Yeah. And in a real world situation, often like I might not want the ID in that CSV data for that exact reason. Or if it's a dump of data, maybe from some other database, then indeed I would have to do an extra step to update this. And we'll probably come back to that one later because that one can get a little tricky. But yeah, that is an excellent point. Let me go ahead and let's create a lockers table just so we can see these two things. And again, I'm getting a little ahead of the curve with table relationships. We're not really going to dig into them that much today, and the assignments don't cover them. But I just want to do this to help illustrate the word relational in relational databases. So it's a good practice to always give every table that you create a primary key, and to make the primary key be its own thing and totally separate. Even though for my locker, I have a locker number and I know that it is going to be unique and it's going to be an integer, and we'll just say int. And I think it might need to be like that. I might need to double check if I have the order right here, but that's okay. And I am going to double check to make sure I've written my foreign key that defines this relationship correctly. And we'll just pull up the Postgres docs real quick. And in fact, I think I overcomplicated it. I can just say references. So this should just be, it looks like it's probably a big int, references, students, and then it looks like instead of .id, I in fact want to be in parentheses. And I'll double check that. I'll see kind of what the Google result example says. Yep. And indeed, they show it here as well. By the way, you don't need to capitalize things in SQL. It's done for readability purposes. So it's more of a convention for other programmers to help read the code. But SQL doesn't care. What SQL does care about is these semicolons. If I didn't have that semicolon, SQL would not know this was the end of this create table statement and we'd get an error. Rick, yes, sir.
Quick question. I know Postgres is open source, so I'm sure somebody's come up with it. But what you're doing here with all your tables, is there a command line tool? Because I know there's one in C#. All right, so you created your classes in your Python code. Is there a command line tool that will take your classes in your
Right.
Python file
Right.
and go on and create those tables?
Right. Because you're basically saying, like, hey, we have this student class and there's a lot of similarities here. Am I going to have to write this out by scratch every time? There is, however, it's part of the Django Python web framework that we'll learn about later. And what you're referring to is called an ORM, or object relationship mapper. And when we get to Django, we won't be writing SQL. We'll be writing classes in a special way, creating what's called a model in Django, and Django will then generate the SQL that's used to create the table. But right now we're going to focus on SQL sort of for the learning purpose of digging into SQL and Postgres.
No, that's cool.
Yeah, but yeah, that's a great question. And that's a common feature of web frameworks, is what's called ORM. Yeah, it's a great question. So we have some SQL here and we can kind of see what this looks like, right? Let's step back a bit and let's talk a little bit about Postgres on the command line, where it lives and how to work with it. And then we will come back to our SQL. And I'm just going to go back to my terminal to make sure I'm where I want to be. Right, we've done a little bit of visualization, but let's talk now about the Postgres database engine and pSQL. So let me hop over to TLDraw here. And in fact, let's maybe go back a bit, and let's go back a bit to our diagram talking about ports on a computer. And we'll kind of just pull this off to the side just so we can have a clean field. So the other day, we were talking about VS Code Live Server, and we were talking about ports and how on my computer, it's running its own little network. And I can have all these different programs communicate over different ports. And there's thousands, there's at least 10,000 ports on a computer. And there's sort of a convention around ports, like anything 8,000 and above is sort of fair game. Well, Postgres by default, when you install it, is configured to use port 5432 on your computer. And so when we did our install fest and installed Postgres, it's running what's called as a service in the background, essentially on my computer, and it's running on port 5432. And we'll talk a bit more about this. There's a bit more to dig into there. So we'll come back to that in a bit, but to kind of start investigating this, let's poke around with Postgres a bit. So on a Mac, I believe I can run the command brew services, and we might need to give it a minute. And in fact, I'm not running Postgres this way with Homebrew. I forget. Because years ago, I installed Postgres a different way with this sort of special software for Macs. But for those of you on Macs, if you run brew services, you should see Postgres listed here. I have to check the command to do the same for Linux for Windows WSL2 folks. I'll try to drop that in the chat later. And then here in this sort of like visual tool, I can sort of see I have Postgres version 14 running, and there's a lot of different databases that I've created, right, over the course of teaching many classes. And I never ever use this visual interface. If I wanted to, I could stop and restart Postgres. But this is just to emphasize that we've had the Postgres database engine running in the background on our computers the whole time. And when we use the pSQL command line program, we will be talking to it over port 5432. And so what is Postgres? So we've got two things here. And let me give our diagrams a little more real estate. One thing we have is pSQL. And pSQL is a command line program, and we use it to talk to Postgres and interact with Postgres. And so then over here we have Postgres, which is the same as, like, the full formal name is PostgreSQL, but you will just hear everybody call it Postgres. And the Postgres database engine is running on my computer, and it can have many different databases, as you kind of saw before when I pulled up that visual tool. And over here, when I typed that pSQL command, what it's showing me here in the command prompt, over here on the right side, the left side of the screen, is the name of the database I'm currently connected to. And if I type /L, it gives me a list of all the different databases running in my Postgres engine. Because a database engine can run a lot of different databases. We might have one for the accounting department. We might have one for, the user software team. We might have one for advertising and for analytics and so on. And we'll dig more into pSQL in just a minute. But I just want to emphasize that we can have many different databases running in one instance of Postgres. right? And I can connect to different databases and interact with them. And then each database can have a whole bunch of tables. It doesn't have to, but there's not much good in a database if it doesn't have tables. So, here's an example of our students database, and we have students and lockers. And then over here in some other database, we have some other table. And each database has a name. Maybe this one is called Students DB. And this one is called just something. Postgres also has user accounts. It in fact has another table that I think is just called Postgres. If we list all the tables here and we hunt through it. And so it's hiding right here. It's a little hard to see. I'll kind of annotate it. So this database here named Postgres, this is where Postgres stores the user accounts of Postgres users. So during InstallFest, we created a user for you, and you can create different database users and use that to manage permissions. And so this is sort of the Postgres's administrative database, and we really don't want to touch it. And it has some other stuff as well. And we don't have to worry about it too much right now, but I just want to point out that it exists. So when I'm using pSQL on the command line to talk to Postgres, there's a bunch of things that are actually happening. Because, and I just quit pSQL and we'll talk about the commands in just a moment. But when I type pSQL all by itself, I'm connected already to a database, but a bunch of things have actually already happened. So pSQL is a command line program I can use to connect and talk to Postgres. I could use it to talk to a Postgres server running somewhere else over the internet. And in fact, when I'm typing pSQL, there's a bunch of arguments that kind of happen under the hood. One is for the host name. One is for the port name or the port. One is for the database name. I'll just say DB name. And then one is for the username. But what pSQL kind of does for us is it gives us some defaults. So I could do pSQL-h localhost -p port 5432. And localhost, remember, is my own computer, my own local network on my computer. Database name, Adam C. Username, Adam C. And let's see here. What did I do wrong? Fatal, could not set printing parameter. And we're going to cheat just a little bit here, because pSQL is also a bit of a pain. And it might be, I just got, yep, I wonder if it needs to be a lowercase p instead of an uppercase p. So let's try psql -h localhost -lowercase p 5432 dash u Adam C -d Adam C. And let's try lowercase d. And there we go. So this is some of the joys of pSQL. Its interface is a little bit of a pain, as you all can see, and it does care about upper and lowercase stuff. But what I wanted to illustrate here, once I got this working, was that if I just type pSQL all by itself, it's actually inserting a lot of default values, right? And so what's actually happening is and for the database name, it uses my Linux username. And I'll just say just my username. And for the Postgres user, it also uses my Linux username. And for me, my command line Linux username is Adam C. Right. And so if I wanted to connect to a different database, like say a car shop database, I could do pSQL -d car shop. There we go. And if you all can see over here, the prompt says car shop, and that tells me the database that I'm connected to. So let me just pause here and see if folks have any questions, because this is, I think, is a key point. The good news is, because of InstallFest, you all should just be able to run pSQL and then be good to go. Okay, cool. Let's keep on rolling. We're gonna dig a bit more into some pSQL and Postgres commands, as there are a range of them. So let me go ahead and set up a little diagram here to help us as we build this out. And there's got to be a way to make these stickies bigger. Hopefully they will get bigger as we go. And we've got Postgres commands. And we've got terminal commands. And in just a couple minutes, we'll have SQL commands. And there can be a bit to keep track of here. I'll make sure to share this with everyone, and I do recommend sort of building up a notes file. So these Postgres commands, they're really pSQL commands, right? And so the first and most important one is this /q. And I might sometimes say Postgres, I might sometimes say pSQL, that think of them as interchangeable, because pSQL is our interface to Postgres from the command line. If I type /l, it lists all the different databases. And if I expand, you can see here the database name, the owner, some other information about them. And if I want to connect to a database, I use /c. Once I'm in a database, I might want to describe the database and see all the different tables. And so here with that /d, Postgres calls it relations, but it's really tables. And this other sequence stuff is more advanced that we'll learn about later. And so /d will list all the different tables in my database. On the command line on the terminal, there's of course pSQL, which we can use to connect to Postgres. And there's some other interesting commands here. When we install Postgres, there's actually a create DB command that gets installed. So if I run create DB foobar, in Linux design principles, silence is golden. So this means this succeeded. And if I do pSQL -d foobar, I'm indeed now connected to the foobar database. It does not have any tables. I can actually run SQL from here in pSQL. So I could do create database hello world. And I see this create database message telling me that this database was successfully created. And if I want to connect to my hello world database, I use Command C. And if I want to destroy a database in Postgres terms, that's called drop. And I have a typo here. So let me just clear the terminal and get rid of this offending underline. And here we see there's an error. When I'm connected to a database, it won't let me drop the currently open database. But if I wanted to drop, say, the foobar database, I could do that just fine. And also this is because my Postgres user is a super admin, as all of yours should be set up on your Postgres. You know, for a real Postgres used by a company, most programmers would not be able to just like, you know, randomly delete databases. And from the command line, along with that create DB command line script, when we installed Postgres, there was also a drop DB command line script. And these get really useful because sometimes it's just quicker and easier to do this from the command line. We've already seen this create table command in SQL. Now, and let's create a database and we'll call it students. And it already exists from before. So let's get rid of it. And now let's create it. And now let's connect to it so we can create some tables. Now, if I wanted to, in here, I could type create table students and type out all this stuff. Postgres does not execute anything until I add a semicolon. So I could type a bunch of lines here. Close my parentheses, add the semicolon, the table's created. If I want to delete a table, I can do drop table students. Or excuse me, drop table. I think I created it singular, not plural, which is a common point of confusion. But this starts to become a bit of a pain, frankly, and you really don't want to do like anything more than simple queries from the pSQL command line. What's way easier is to write the code here in a file in VS Code and then run the SQL file. And so to do this, first, I need to make sure I'm in the directory where my SQL file is, because we're going to be dealing with relative paths. And then let me go ahead and connect to Postgres, and let's just go right to our students database that we want to do this for. And now let me make sure I get my pathing and commands right when running this. So this /i command is how we run an SQL file. But what's important is under the hood, pSQL is using a relative path. So I need to make sure I can do this because I made sure that I opened pSQL and connected to Postgres from the same directory that this was in. Otherwise, I might have to, if it's a directory up, I might have to do that, or I might have to do, SQL files, something like that. But because we made sure that we're in the same directory like this, I should just be able to run it this way. And we see these two create table statements for the students table and the lockers table. And we see here that those tables are created. Sequences are how Postgres sort of keeps track of unique IDs under the hood. And we won't get too much into that now. And so we also have /i. To run an SQL file, and this belongs over here. And this /i command is really important. We have this documented in the curriculum repo as well, so it's written down in many places. And we have a couple cheat sheets, but you'll probably want to construct one of your own as well. And so now that I've done this, this is great, right? So far, so good. Maybe though, I want to modify this students table. Maybe I decide I also want to add an email. And so let's just put it here. And it will be a varchar, and it's got to be 50. And I'm just going to keep it simple. And let's go ahead and update our table. Well, now we see an error, right? It says this table already exists. Postgres is not just going to overwrite a table for me. So a really common pattern when you're sort of developing your SQL is you'll add an SQL command, drop table if exists students. And over here, drop table if exists lockers. And this way, I can kind of modify my code. And just like we do running Python on the command line, I can run the pSQL command to execute my SQL. Here we're getting into some more complex stuff that I don't want to get into too much right now, but I will briefly point this out. We aren't going to have to worry about this today, but note this error cannot drop table students because other objects depends on it. Postgres knows that this student ID on the locker points to the student primary key, right? And in terms of data integrity, if we got rid of the students, but we had a bunch of lockers, but this has to point to a student, that's right, that's bad data because this would point nowhere and Postgres won't let us do that. Alex, yes, sir.
How do you pseudocode? Can you pseudocode in an SQL file? Like, is
Oh,
there
like comments?
hashtag? Yes, comments.
Yeah, excellent point. Thank you. I think it's 2 dashes and a space.
Okay, cool. Thank you.
Yeah, great point. And in fact, let's use the VS Code handy dandy command / keyboard shortcut. Yeah, thank you so much for mentioning that. Excellent point. So the way to solve this problem, and again, this is a bit more advanced than what we're going to need to do today, is I need to get rid of lockers before I get rid of students. And now when I run this, we see that it works just fine. And let me just pause here and see if folks have any questions. Tom, yes, sir.
For the SQL command, create table, did you need to give that a name?
Yes, we definitely do need to give it a name. And let me add that to the example here. Yeah, good call. Thank you. All right, why don't we take 5? Because we've covered a lot of ground here. When we come back, right, because we've looked at creating tables, we've visualized tables, we even got a little ahead of things and visualized the relationship. We dug pretty deep into P-SQL as well, right? We have a list of commands. We now kind of know P-SQL's default behavior, and if I wanted to, how I can use it to connect not only to other databases, but other Postgres servers on other computers. And we learned a bit about how Postgres is organized and where it lives on my computer. When we come back, we are going to see how to import CSV data and query that data. And that will give us a really solid foundation to start playing around with Postgres. So thank you all very much, and I'll see you all in 5 minutes. All right, so to kind of recap, we've covered a lot of ground here. We've talked about why to use Postgres. We've talked about what is a relational database. We've talked about visualizing a table, right, with the Draw SQL tool. We talked about P-SQL and Postgres, where P-SQL is the command line program that I use to connect and talk to Postgres, and how if I just type P-SQL by default, it's actually setting a lot of default values for hostname, port, database name, and username. But because of the way we've set up InstallFest, I can just type P-SQL and it connects me to the Postgres running on my computer. And to connect to a specific database, I can use /C and my database name. You can also do P-SQL has /? that lists all of the commands. This is sort of useful. I will just say that I think the P-SQL interface is a little arcane for everyone. It is not just you. And the correct move here is writing some cheat sheets, and we have some cheat sheets in the curriculum and searching for some online. But you can see there's a ridiculous amount of P-SQL commands, and we're just sort of hitting the highlights. And the most important of those commands, in many ways, being the one to run an SQL file, because manually typing out SQL in P-SQL to execute in Postgres is a bit painful. So with /I, as long as I know that my relative path is right, I can run this SQL file and we'll drop these tables if they exist, and then create a students and a lockers table. And in fact, for the purposes of simplicity, I'm not going to worry about lockers right now. Let's just worry about students. And in fact, let's create some students. Now that we have a table, let's see how to create some data. And that's where things start to get fun. So I'm going to add a comment here with 2 dashes. We're going to insert some student data. And we'll do this manually, and then we'll see how to grab data from a CSV file. I think we'll see a little querying before we get to the CSV. And when I want to add data to a database, we call this inserting. So the command is insert into, and then the name of my table, which is students. And now I need to give the different column names that I want to add data for. So Postgres will automatically take care of the ID for us. So I'm going to do first name, last name. I'm not going to worry about the email field, which I made up just to show an example of modifying the table. And we'll do age. And we'll do grade. And then I say values. And remember that SQL doesn't care about new lines. It only cares about the semicolon as indicating like the end of a statement. So all this stuff that I'm going to write here now could in effect be one super long line, but we write it this way for readability. And so each row now within these parentheses is going to be a first name, a last name, an age, and a grade. Rick, yes, sir.
Yes, whenever you're not adding the email, is there, does Postgres have a tag for cannot be null?
It does. Yes.
Okay,
I believe so. Constraints are a little out of scope of what we're covering today, but I think we would
no,
say,
that's okay.
yeah, it would look something like this. That I would need to double check that I've written it correctly, but you're bang on, and that's a very important constraint to add or not add.
Okay,
Um,
yeah, cool.
yeah, great question. And in fact, primary key under the hood adds a not null constraint. The primary key has to exist, but Postgres will also generate one for us because we've added this serial keyword here. And I'm just sort of adding a bunch of people here. Cricket, yes, sir.
So when you put the email is like null or something, like how they gonna recognize like number or string when you type in the email?
So right now, it should be okay for the email to not exist, to be null. And so right now, because over here, I tell Postgres what columns I'm entering data for, it will just ignore email and it will use a default value probably of null for the email. If I wanted to add an email, I would add it here. And then indeed, I would have to add emails, like this. But just for simplicity, I'm just not going to worry about it right now. Does that help answer your question a bit?
All right, sir. Thank you.
Yeah, great question. Great question. And let's add one more person. And what we'll see in a minute, and it looks like I have a typo here. We'll see if we can discover it.
Is it because A is used again?
It
Oh,
might
no.
be the double quote. Yeah, Postgres gets a little funny about double quotes and single quotes. And it doesn't like trailing commas. And so most importantly, I need the semicolon at the end here. Because again, from Postgres's perspective, this is all one giant line. We're just breaking it up onto separate lines for our own readability. And it's the semicolon that makes the end of a line of SQL. And this is by far the easiest programmer error to make. And it happens all the time. So that should always kind of be the first thing that you check. So now, fingers crossed, we're going to run our SQL. It will drop the existing student table, recreate it, and then insert all of this data. And it looks like, in fact, I made an error. And this is actually a great example of where we have to really start thinking, and a great example of how databases enforce data integrity. We already had created that lockers table, and I commented it out because I just didn't want to deal with it. But I forgot that the lockers table already existed. And because lockers connects to students through this ID, we're just going to make sure we delete the lockers table. And this if exists is here, so that if the lockers table isn't there, it doesn't throw an error. So let's run our code again. And we see the drop table statements executed successfully. We see create table, and then we see this interesting insert statement. And I can't recall what the 0 means, but I believe the 5 stands for 5 new records, meaning we've inserted 5 rows of data into our student table. By the way, if you want to see more information about a particular table, you can do DT and then the name of the table. Or actually, I think it's just D and then the name of the table. And here we can see our students table, and we can see each column and each type And we can in fact see if null is allowed or not and some other constraints. But now that we've created some data, let's look at it. And the way that you query data in Postgres is with what's called a select statement. And you say select, you tell it what columns we want information for. We say from, and then we give it the name of the table that we want. Now, I forgot to add a semicolon, so Postgres doesn't know that this line is complete. So that's, again, by far the easiest mistake to make, right? So in fact, this is really how you want to write it. And I missed that semicolon on purpose. And here we see a sort of result table with the first name of all our students. And let's go ahead and let's put this here. I'm going to put it sort of in the SQL file so we can have a record of things. And if I wanted to look at two things, I could do first name. I could do, maybe I want to mix up the order for some reason, and we'll do grade, and we'll do last name, and we'll do ID. And now if I run my code, it's actually going to drop the table, recreate it, insert the data, and then run my queries. And we see the first query result here, right? And then we see this next query result here with these different values. And you can do all sorts of interesting things. If I wanted to come up with an alias for a column, I can use the as keyword. Maybe I want to call it student ID when I'm generating the report for management. Maybe I want to see all the columns, and I can use the star or the wildcard, and this will give me all the columns. And so this is commonly, like when I'm just fiddling around, this is what I'm usually doing to make sure data is what I expect it to be, because it's fast and it's simple. So this is pretty cool, right? This is a good start. We can not only query, but we can filter. So let's look at all of our students where the grade is an A, right? And we see that John and Emily have an A. And we call this where statement here a where clause. And our SQL statement can have different clauses. And often you see this on different lines, and you might see something like this. Because as I'm writing my SQL, this becomes very readable, right? Here's what I want. Here's how I'm filtering. And so I could take this and I can run that. I could make a fancier query. Let's see where their grade is an A and their age is greater than 18. And I think this will actually be no one. My apologies, that was the wrong query. Let's do and age greater than 18. And indeed, that's no one. And we see the 0 rows message. We can do some really interesting things. I can sort of do counting, or they call it aggregation operations. So that's giving me a count of all the students in the table. Maybe what I want is all the students who have an A. So I can see that 2 students got an A. So count is what we call an aggregator. And I can even get a little fancier. Maybe I want to, from students where age between 16 and 18. And to go back to the count, I can also sort of group things together. And again, this is getting more advanced. We're not going to have to tackle a lot of this stuff today, but I just kind of want to give everyone a preview of the different kinds of things we can do. And now I can use this special clause group by. And so this is going to group all the results by their grade, but then it's going to count the number of students for each grade. And so we see grade, we see the grade count, and the group by is grouping, and then count is counting within each group. So this is, again, a bit more advanced and more of a preview, but just to show like how powerful SQL is in terms of working with data. I think the last thing I want to show is just sorting and limiting, and then we'll pause for questions and we'll look at working with CSV files. So I can order students by last name. I can reverse the ordering. Oh, and let me just put this here for posterity. And if I want to, I can also limit the number of my results. Maybe order by grade, limit 3. And now I have the top 3 grades out of all of the students. So once you start combining these things, it's very powerful. There's a lot more you can do, but I think this is a good kind of overview. So I just want to pause here and see what questions folks have or what people are curious about. Alex, yes, sir.
Yeah, so I guess I got 2 questions. The first one would be what, where and how is the main input of the data? How would this file grab the data besides you typing it out?
You mean, how do I get this data here in? Or once that data is in, how do I run all of these different queries?
Yeah, what would be, I guess, it's really hard to pose this question. Yeah, how would your file consume data? I guess how would it receive the data in the most typical fashion?
Put that in your Python file.
You mean like if I've got a Python program that I want to talk to a database, how do I get the data from there?
I guess so.
Yeah.
Or like if somebody wants to enter the information, Michael Brown, he's 19, he's B, would that be coming from like an interface of some kind?
Right.
Yeah.
Great question. Great question. So there are a lot of different ways to connect and talk to Postgres. One is with pSQL, right? Another is by running an SQL file. And we can execute queries this way. You can have pSQL print out these results, but that's not that useful, right? And really you're asking like, how do I integrate this into my code? And I'm just going to kind of pseudo code this right now. But like, I might have some Python code and maybe well, I'm not going to get too much into like how to connect. There's a library that I would use. Right, but maybe there's some sort of connect method or something, and then maybe I would do results equals DB query. And at this point, I'm passing in some SQL. I would say select, star from students, order by grade, ascending, limit 3, right? Maybe this becomes an F string, and I can decide how many top students I want to see. And that should go there. So this is a really simple example. And this isn't exactly what the Python code would look like, but hopefully this sort of like illustrates the point a bit, is that we'll have a library that can connect to a database, and then in our Python code, we can run SQL. And Python will give us actually a lot of helpers to make this less painful, but this is the essence of it.
Okay, cool. And then, yeah, you answered my second question, was about how do you be connecting it to, I guess, Python, or does it work with other languages?
Yeah, you can absolutely connect the database to any language you want. And that's kind of the beauty of it. And pretty much every language out there has a library for connecting to databases, because this
Okay.
is just such a core part of programming.
Okay, and it's not like common practice to be manually writing the data inside the SQL file like you are right now, just for example's sake?
No, it's not.
Okay.
Yeah, no, great questions. And we'll start to see these dots connect more when we start to look at Flask as well. The last thing I want to show is not quite what you were touching on, but sort of similar, which is importing data from a CSV file. Because this command has a couple more steps, and just to kind of show how to do this. So let me go ahead and run that command, and then we can kind of wrap up and review. But as to your point, Alex, yeah, that is a really good question. And again, what we'll see is, if I kind of hop back to some of the diagrams that we've been drawing, and we kind of scroll all the way down here to, where's the one that I was looking for? This is not the one that I made earlier today, but this one will do the trick. Or actually, here we go. This is a slightly cleaner version of that same diagram. What you're asking about here is, right, once I have my Python code, how does data get into the database and get out? Data comes in all sorts of different ways. We will have some sort of library that we can use that will do a lot of the work of connecting to a database. And then we can write Python code to read data from a database and to insert data. So we won't have to do it directly, but we could, in fact, and let's just take this, and I'll just stay in the README here while writing this. I could, in fact, write some Python code that looked like this. Right, where I'm adding a student, and we connect to our database, and maybe I'm going to construct my query like this, and we say, insert into students. I'm just going to do first name, last name to keep it simple. Values, and then we have, new student dot first name, new student dot last name. And again, this is just really pseudocode. but we would maybe construct our query and grab data that's passed into a method and insert it. So we won't actually, Python gives us a lot of helpers, but again, to sort of get down to the fundamentals, we absolutely could do this, right? Where we write an insert statement, but we're passing in data that gets into our Python program. And we'll actually build on this and go further, but this is good to see as well, because this is sort of like the heart of it. So hopefully that's useful to see. Let's touch on working with the CSV data, and then we can kind of review and wrap up. So when I'm working with CSV data, I have to keep in mind where I am in my file system. So I'm in the same directory as the CSV data. And to copy a CSV file, and let me just drop database or drop table, just to make sure I don't do anything silly. Let me actually just I'm just going to copy this, and we're going to drop table student, drop table students, and we're going to create it again. And this is just to make sure I don't run into issues with like duplicate primary keys or anything like that from all the data that we've been playing with. And you can see how forgetting that semicolon can really cause problems. But now I can see that I have a students table, but it's empty. And so now let's try to copy from our CSV file, and pSQL has a copy command. And then I give it the name of the table. And then I say from, and I give it the path. And with luck, I can give it a relative path, but we'll see. The relative path might in fact cause some issues. And I need to tell Postgres how the CSV file is organized. The delimiter is what we call the character that separates each item. Most CSV files, as the name comma separated value implies, use commas, but there are some that use spaces or that might use a dash or a semicolon. So you can actually set the delimiter. So we have to just tell Postgres that it's a comma, and we tell it that it's a CSV file, and we need to tell it that it has these headers, that this first row is headers, and Postgres will use this to figure out what column the data goes in. And let's see here, invalid input syntax for type integer A. I wonder what the issue here is. And it looks like column age. Tom, yes, sir.
Is this because of our ID conflict? How are we resolving that?
Yeah, I'm not sure. I think let's see, I may actually need to get a little help here because this can get a little trickier. I thought, let's see, we may have to circle back to this one. Copy CSV file IDs. So I have the file path, I have width. I may need to say format CSV header. Ensure it's not defined as serial, or remove the serial. This may be related to the IDs. I'm not totally sure, to be honest, because the ID one always throws me a little bit. There is an extra step that we have to tackle. So I may be a little bit lazy here, and let's see if this works without it, and we can go from there. So let's see here. Copy students, line 2. for type integer column ID John. Yeah, so I apologize. This one I may need to come back to just because the formatting gets a little persnickety. I think that something is going on here with the header, and it's trying to insert John into the ID now is what's happening based on this error. So I apologize, but this one I may have to demo later. Because I don't want to get too lost in the sauce on this. So why don't we pause here, and I will make sure to share in the channel the correct way to do this. The IDs themselves, it won't cause an immediate issue. It causes an issue down the line with creating new IDs. I think what's happening is something with my CSV header syntax isn't quite right. I wonder if like this is the format that I need to use. Let's see, we can take a quick look and see if the Postgres docs are a little dense here. We might have a good example. Yeah, I think I have my format a little wrong because it looks like with and then this format CSV. So we can try that. Otherwise, I may have to come back to this one. I apologize. Yeah, because we see a couple different ways of doing this here. Let's see here. We have copy students from data CSV delimiter. Yeah, I apologize, guys. I'm probably not going to be able to debug this one live. I'll share the right way to run this command a little bit later in the Slack channel. Tom, yes, sir.
Can you try putting a with in between the CSV and delimiter real quick?
Yeah, like with, and then I think it was like this.
I think it's if you put it in between the path and delimiter, because I think we're saying delimiter is the formatting for the CSV header. So yeah, right there. Oh, okay, never mind.
No, it's all good. I'm not, to be honest, the delimiter, I'm not even sure if we need. Yeah. Yeah, I'll debug this one offline and share the correct way to run the command. As this one does get a little persnickety. Yeah. Because that syntax should be working. The other possibility is I might need to use an absolute path. Which would surprise me a bit, but if I'm looking at a lot of our example code, that's what I'm seeing. And so we can try this with an absolute path and see if that does it. And I'll put in double quotes just to be safe. And I think it's then part 2 / data.csv.
Missing a Y.
And oh yeah, and I am missing the Y. Thank you. Yeah, and I think debugging this one live is gonna be a bridge too far. So let's stop here. What other questions do folks have or folks are curious about when it comes to the querying that we've been doing or the insertion of data? Okay, awesome. Thank you very much, folks. I'll follow up with the correct format for that copy statement in our Slack channel. And hopefully this is useful and sets us up to start playing around with Postgres. And really the important things to focus on right now, I think, are getting comfortable with pSQL on the command line, creating a database, creating some tables, executing an SQL file from pSQL, right? Like we saw with the /i, and creating some data and querying it. So thank you very much. And I'll follow up shortly with the copy statement. And let me go ahead and stop our recording.